Hello and welcome everyone. This is going to be the first video in 4 videos where I detail how absolute value inequalities work. Just like our first inequalities, we have to first make sure that our x is fully simplified for. Today we're going to be talking about making sure we understand what absolute value of x equals. So let's go ahead and jump into the notes. Just a quick note, it'll take a few seconds for the screen to transition. Okay. So when we talk about numbers, we can be very precise with the adjectives that we use. It's important to understand that absolute value is more concerned about a number's size than where it falls on the number line, aka its direction. As you guys know, positive numbers are to the right and negative numbers are to the left. But it's easy to confuse the idea of greater with big and the idea with less and small. So let's make sure that we understand the difference between these words. You'll notice that I will type things at times and I will also handwrite things. Basically, if I put anything on the screen, make sure that you copy that as well on your notes. Okay, so again, when we talk about a number size, we're referring to its bigness. So a number's size is how far it is from 0. So small numbers are close to 0, large numbers are far away from 0. Let's just draw a quick little diagram so that we can articulate that. So if we were to draw a number line, here is 0. Numbers close to it would be small. Yeesh. And numbers far away would be big. So if you look at this diagram, this means that there are both big positive numbers and big negative numbers, because all they have to do is be far away. Direction. So we would say a number is greater than if we are further to the right. Similarly, a number is less than if we are further to the left. So again, we're going to draw another number line and we're going to see how the idea of big and small aren't exactly the same as less than and greater than. Okay, number line. So we'll choose 2 numbers. Of course, 0 is in the middle as always. We could have -10. We could have 3. So I would say that 3 is greater than -10. In other words, it's further to the right. And I would also say that -10 is less than 3 and that it is further to the left. However, this would be big and this would be small. Now that we've sorted that out, let's talk a little bit about how we would read an absolute value, in particular when it's in relation to an inequality. So as we've always seen, x, the variable, is some unknown number. So when we put x inside of an absolute value, it's not that I'm telling you exactly what x is, but I'm telling you how big it's allowed to be or how small it's allowed to be. So if I were to read the first absolute value inequality, I would read the absolute value of x is greater than or equal to 4. In other words, this is telling me that whatever number you choose has got to be at least 4 away from 0. So let's go ahead and write that down. So the absolute value of x is greater than or equal to 4. Similarly, if I were to read the second absolute value inequality, this is the opposite case. This is saying the absolute value is less than 7. That's implying that we're supposed to stay close. I could be 1 away, 2 away, 5 away, but I can't be 10 away. I have to be less than 7 away from 0. I guess I should write the number too. Yeah. Okay, so now let's graph these things. They're not terribly complex to graph, but we do have to make sure that we're keeping track of our closed circles and our open circles. So if I were to read question 1, and let's actually switch colors so we can see some things. Okay, I say the absolute value of x has got to be less than 5 away. So that means if I'm looking at 0, I'm going to put an open circle at 5 and an open circle at -5. And I have to be less than 5 away. So that means I got to stay close. So I'm going to shade in the middle. However, over here at question 2, we've got a greater than problem. So x, the absolute value of x has got to be greater than or equal to 2 away from 0. This means 3, 4, 5, 10. That's going to work. However, this time I'm going to put a filled in dot at 2 and a filled in dot at -2. And we're going to shade away. Again, we must be greater than 2 away from 0. Just like the previous example, we got less. So I'm going to put open circle here, open circle there, and I have to be less than 3 away from 0. So 2 and 1 are good, but you know what would not be good is 10. Oh, again, we've got greater than, and I'm going to be using some filled in circles. So filled in at 7, filled in at -7, going this way, and going this way. Last 2 examples. Again, we got a less than. This time it's with filled in circles. So -2, +2. The absolute value of x is less than 2 away from 0. And this is kind of a funny example. The absolute value of x is greater than 0 away from 0. Let's first talk about how the absolute value of x could equal 0. That just means you are 0. If you are 0 away from 0, it means you are literally on 0. So the only number that we are not allowed to shade in is 0. But I could go anywhere to the right, and I could go anywhere to the left. So this is the basics of reading the absolute value sign. The absolute value tells us how far away we are from 0. Therefore, if your absolute value is less than a number, you're going to stay close to 0. And if your absolute value is greater than some number, then you're going to want to push away from that 0. So at this point, go ahead, try the first assignments, and when you're done with that, go ahead and watch the second video.